5 minutes, have a break for 5 minutes, and then I will introduce my part for the fault debugging and maintenance.你在播放视频吗？放个视频吧。Hello everyone, this is Tenants from VEICHI. Just now Mr. Jason and Mr. Carl introduced the function setting, wiring, system configuration, and system selection. If there is any problem with the system configuration, wiring, or even parameter setting, inverter could display fault or even be damaged. So today, I will mainly introduce the fault debugging and maintenance of solar pump inverters. One of the first things is that we must be familiar with the VFD and the keypad operation. While using, you will find there are 4 kinds of displays. Parameters, like for SI23, the parameter from F01.00 to F14.00. The fault displays like overcurrent fault, overvoltage fault, and so on. Warnings you can also call alarms, such as the dry run alarm, waterfall alarm, and so on. And the prompts. Prompts mainly is not damage or fault. Like the PON is displayed when power on. That means that the inverter and the control board is powered. Or copy and load means the parameter is uploaded or downloaded. Knowing the meaning of these displays, we could get into the introduction today. I will introduce how to troubleshoot the problems when the VFD is abnormal working, alarm, error, damage, and in the final part, a feedback table with the necessary fault information will be provided, which could help us find the problem better. Abnormal working refers to the inverter or motor performance that could not meet a user's requirement. Like keypad displays for dash. When you do some parameter setting, you will find some parameters could not be modified, and then keypad displays this dash. This mainly happens for some parameters that just allowed to be changed at stop state, such as the motor specifications, the parameter group F5. If you want to change the motor rated current, rated voltage, or even poles at running state, you will find inverter displays this fault. Sometimes the motor could be heated up abnormally, means the temperature is very high. If the cooling fan and the environment is good, then we need to check if there is an excessive load, such as the impeller is blocked, the motor could heat it, or the inverter is running at low speed for a long time, especially below 20 Hz. For a long time running, the motor could also heat it. When the motor cable length is too long, the motor could vibrate a lot. And just now Mr. Carr introduced, this time you need to install output reactor or output filters. Otherwise, it may be even damage the motor. Here I will introduce several parameters. If they are set improperly, the inverter could have abnormal working. Like the F00.02 running command channel. There are 3 running command channels: keypad control, terminal control, and RS485 communication control. The keypad control and terminal control are most popularly used. And F0, 0.03, the frequency given source. F0, 0.11 and 12, upper limit frequency and lower limit frequency. And F0, 0.14 and 15 for the acceleration and deceleration. If the running command is set improperly or the frequency given source is set improperly, you may find the inverter could not rotate or rotate not at the target frequency, such as the inverter may be run at 0 Hz. For some motors rated 60 Hz, you need to set not only the target frequency, but also need to change the upper limit frequency, max frequency, and so on. Otherwise, you can find that the target frequency will be limited by the upper limit. And F0, 0.14 and 15 need to be set according to the load, especially for the high inertial load. The following problems are mainly due to the improper setting of these parameters. Like the motor doesn't rotate when you input the running command. Usually this is because the running command or frequency limit are set incorrectly, as what I introduced just now. If the F0, 0.02, the running command is set to keypad run stop, but you use the X terminal to control the running and stop, you will find the inverter doesn't run, even this X terminal is valid. If the given frequency is set to 0 due to the wrong frequency given source, or the given frequency is lower than the lower limit, the VFD actually also operates at 0 Hz this time, but motor is still not rotate. Additionally, an emergency signal input will also make the inverter always stop. Only when this emergency stop signal is cleared, inverter can try to run again. If the output frequency could not reach the target frequency, we need to check if it exceeds the upper limit. Like if the upper limit is 40 Hz, but you want set to 50 Hz running frequency, the software will limit it to maximum 40 Hz. If the upper limit is set correctly, but you still find the motor speed could not be controlled by the frequency command, this time the frequency setting command may be wrong. Like if you set F0, 0.03 as PID control, the motor will just run according to the PID process, but not the F0, 0.08 keypad given frequency. In a summary, all the frequency inconsistent problem shall check the frequency given source, frequency upper and lower limit. But if the motor acceleration or deceleration has some problem, it could be the acceleration and deceleration time, or there may be some excessive load with high inertia. For the high inertial load, such as the ventilation fans, the stop process takes long time, and you must consider this when you're setting the deceleration parameters. Another important parameter is F0, 0.16. F0, 0.16 could select the rotation direction or prohibit the running direction. If you find the motor run in one direction or in the opposite direction, like you press the forward running button but the motor runs reversely, this time you could exchange any two-phase wiring of the UVW terminal or you can directly set F00.16. The first digit of F00.16 could exchange the running direction directly without any varying change. And you could find the other digits of F00.16. For the alarm treatment, alarm are those protections which could be reset automatically when the external conditions get normal. All the alarms start with the character A, such as A.LFR. Mr. Jason just introduced it. It is a low-frequency protection alarm. Whenever there is any alarm, some information is needed. The solar panel specifications like the VOC, open circuit voltage, VMP, the operating voltage, and solar power, solar panel strings, and panel numbers in each string. Also, the motor specifications, VFD specifications, are all needed, especially the C02 parameters. We could know the real-time output frequency, given frequency, DC bus voltage, current, and so on through these parameters. Some customers may not fully understand the difference of VOC and VMP. VOC is open circuit voltage and VMP is operating voltage. You could understand the VMP as the actual output voltage while operation. The VOC could even be tested at night, but with load, you will find the real-time working voltage and current are different with the VOC value. So sometimes if some customer told us that the VFD, if without load, it could run to 50 Hz, but with load, it could just run at 30 Hz. This time, actually, the customer don't fully understand the VOC and VMP difference. When he tested the DC bus voltage with load, he will find the DC bus voltage this time is very low. That's why we need these information for the solar specification and the C02 parameters. These are the common alarms we could meet, like the A.LPN, sleep alarm, low frequency alarm, minimum power alarm, dry run alarm, overcurrent alarm, and waterfall alarm. The first three alarms for sleep, low frequency, and minimum power usually displays when the sunlight is not good, the solar power is not enough. No matter it is cloudy or the solar panel is damaged. The dry run alarm or overload alarm are related with the output current. When the output current is too low, lower than the protection value, it could display the dry run alarm. But if it is too high, it may display the overload alarm. VEICHI dry run alarm detects the output current, and we could also support the dry run protection sensor solution. Just now, Mr. Jason also introduced that. And the waterfall alarm display just displays when the tank water is full or when the water in the deep well is not enough. Their working principle for these alarms are similar with each other. Each alarm has 3 parameters for the protection value, protection time, and recovery time. And here I will take a low frequency alarm as an example. When the input power is not enough during operation, the output frequency will decrease. If it drops lower than the F14.14, the low frequency detection frequency, and after the time set by F14.15, inverter will enter into the standby state and the keypad will alarms A.LFR. When the frequency recovers and after F14.16, the low frequency recovery time, inverter will automatically resume to running. And this working process is similar to the other alarms for dry run alarm, sleep alarm, overload alarm, and minimum power alarm. The waterfall protection is a little different. It is based on the software logic of X3 and X4 terminals, which are used for the high-level sensor wiring and low-level sensor wiring. You could set the detection time and the recovery time as well. Considering the protection range, the alarms are mainly displayed according to the signal trigger sequence, especially for the low frequency alarm, sleep alarm, and the minimum power alarm. Which one is triggered at first, and then inverter will display this alarm. Like if the voltage is lower than the protection value, but the power is still enough, or you cancel the low frequency protection, this time inverter will just first display the sleep protection. So whenever there is any protection, if the VFD displays these alarms, we could disable them at first. If you set the detection or protection point to 0, this alarm will be invalid. And then we could check if the inverter display any fault. In case this alarm could have some real fault. But please kindly note that there are two recovery modes. If the recovery mode is selected as manual recovery, the alarm will not disappear automatically, even when the external condition is normal. Of course, the default setting is for automatic reset, that is F14.26. And there is, I also list another parameter, F14.46. This is a solar pump function selection. Actually, you could think it is some MPPT function selection. This parameter could disable and enable the VOC voltage rising update function and the faster frequency falling function. And later I will introduce where we could use this parameter F14.46. There are also several alarms we seldom meet, like the LU, OU, and SPD, the low voltage alarm, over voltage alarm, and overspeed alarm. The low voltage alarm and the over voltage alarm could be eliminated after checking the supply power or the wiring. But for the A.SPD, the overspeed alarm, that is detected when the motor speed is higher than the given speed. Or you can think the motor frequency is higher than the given frequency. This is actually due to the high voltage configuration as well. When the bus voltage is too high, inverter will try to increase the running frequency to consume the DC bus voltage and DC power. If this condition lasts for a long time, lasts for the protection time, this alarm will occur. So when you do the solar panel configuration, please follow the principles and the configuration values according to what Mr. Carr just introduced, especially the VOC and VMP range. Otherwise, if the VOC is too high, it may display the A.OU over voltage alarm or overspeed alarm. If it is too low, it may display the A.LU low voltage alarm. And here is an example for the alarm treatment. One day, a customer contacted me and informed that inverter worked normally with solar power, but it has some problem with the generator power. And he shared me some pictures and videos. From the pictures and videos, I found it displays a fault. Actually, it is an alarm. So I suggested him to cancel the dry run protection and low frequency protection and the minimum power protection. in case it covered the real fault just now as what I introduced, he informed me that he already cancelled the protection and sent me the display video again. And you can see we could find it is still 8.LFR. As you can see, it still shows this alarm, and we all know that this is low frequency alarm. That means I already told him to cancel this protection, but actually he may set some other parameters, so this protection is still valid. So I asked him to set F14.14 to 0 directly to disable the protection. After that, he told me the inverter shows a new fault display, and we could see it is 8.LU1. 8.LU1 is low voltage alarm. As what I said just now, low voltage should consider the input power at first. So I asked him to set F14.00. F14.00 is a very important parameter, and in the solar product debugging, this parameter could be used very frequently. The F14.00 could set VFD mode, CVT mode, and MPPT mode. If the solar power is enough, and we set the F14.00 to VFD mode, then inverter shall run to 50 Hz. But if the supply voltage or input power is not enough, under VFD mode, inverter will run to a 30 frequency and then display fault, and the fault will be 8.LU1. This frequency is the frequency that protected when the input power is not enough. And this mode is mainly different with the MPPT mode in the MPPT parameters. So I asked him to check the MPPT mode, and you could see I told him to set F14.00 to 2 and F14.06 to 0000. Actually, this time I made a mistake. It should be the F14.46. And after just now set to the VFD mode, we can see that the customer told me inverter is pumping water. So we know that the power is enough and the MPPT mode couldn't work. So we need to adjust these MPPT parameters. This parameter is actually I just introduced in the alarm F14.46. It could adjust the VOC update and the frequency fast falling. You could see in the conversation after this parameter setting, it is pumping water, and inverter works normally. So actually from this example, I mainly want to provide some suggestions. The first suggestion is that videos and pictures are really necessary and could really help a lot when you feedback any treatment or parameter setting performance after each step. Because usually we give some suggestions to tell the customer set one parameter, and he told us inverter maybe give some display or have some problem, but we could not know the problem clearly. This time the videos and pictures could help us know better. And second suggestion, the basic information for the VFD, for the motor, for the solar panels, generators, and some fault description are also helpful. And third and fourth are two parameters, F14.00 and F14.06. F14.00, if you set to 2 for VFD mode, you could judge the supply power and supply voltage is if enough or not. And F14.46, you could adjust the MPPT performance. And then we can go to the third part. The third part is error treatment. Error displays could just happen at some conditions that may damage the solar system or even damage the VFD. All the error display start with the character E, such as E.LU, that is low voltage error. The errors could not be reset automatically as alarms. Just now we know alarms could be reset automatically, but errors cannot be reset automatically. You must need to clear the fault and then press the stop or reset button to clear this fault. The first kind of errors are for voltage error. There is low voltage and over voltage errors at running, stop, acceleration, or deceleration. For the low voltage and the over voltage fault, please check the supply power voltage or fluctuation at first, because if the supply power voltage is too low or too high, or the fluctuation is over range, you will find it displays this fault. The low voltage fault could also be the fan or the cooling fan or the contactor problem, because the cooling fan and the contactor actually share the same power board with the main circuit power board. An overvoltage fault could also be the load problem, especially for the large inertial load. The second fault is for the current error. There is the overcurrent error, overload in the motor side and overload in the drive side. Usually the overcurrent fault has four main reasons. First reason could be the current detection problem. In small power VFD, there is a current detection circuit, but in big power drive, there is Hall sensor for the current detection. If this current detection circuit or the Hall sensor works abnormally, it may detect the false current value and then display a fault. The second reason could be the acceleration or deceleration time. If they are set too short and you for a large load, high inertial load, you can also find it is overloaded. The third reason is some sudden load change, like the pump impeller is suddenly blocked, or if you start a rotating motor again, it may also display the overcurrent or overload problem. And the last fault could be the inverter capacity and motor capacity. They doesn't match, or the motor cable length is too long. There are also some other popular faults like the E.SC fault, the system abnormal, or the OH for overheat. The SC system abnormal, most general problem is the IGBT is damaged. We know IGBT is the central part of VFD. If the IGBT is damaged, you will find the inverter display SC fault directly. If it could be also be some short circuit in the system or even some EMC interference. The OH is over temperature or overheat fault. The IGBT part and rectifier has the highest temperature in the inverter. And there is a temperature sensor around the IGBT. So the fault could be due to the environment high temperature or the bad air ventilation. Also, if the temperature sensor is damaged, it could also display the OH fault. Some unusual fault like LIFE, LIFE, or ILF, OLF, and GND and Hall fault. LIFE is a system left locked. If you set some password or if you set a running left in the inverter, inverter will display this fault when it reaches the running time. In VEICHI VFD, we support the password set and also with the GPIS card and the inverter factory parameter setting, we could set a running time. This is mainly for the rent business or for the part payment is and there is some balance payment, customer could use this function. Once it reaches the running time, inverter will display left blocked. The ILF and OLF are for phase loss protection. Most of our customers may use the single phase pump, especially in the Middle East area and African countries. If they use a single phase pump but they don't set the single phase mode or didn't cancel the single phase protection, the inverter could display this fault. The GND is very easy to understand. It is a ground, or you can think it's a earthing, especially when the motor cable installation has some problem. If the motor cable is broken, the current is connected with ground and it could display this fault. HAL is Hall. Just now I introduced if the Hall sensor or the current detection circuit in the power board has some problem, it could display this fault. According to my experience, just now I introduced lots of arrows, but some users may not be able to identify the arrow code correctly. So whenever there is a fault, you could check the fault tab and fault information in the C01 parameters. Like the C01.00 is a fault tabs and C01.01 is a fault diagnosis information. From C01.02 to C01.09 is a detailed fault information like the fault frequency, fault current, fault voltage, and so on. You could also check the last 2 or even last 3 fault information with this table. So if there is any fault, please kindly provide this fault table to us. We could find the fault information in details. Whenever there is any fault, the checking process actually should be the peripheral equipment to check at first, and then we do the inverter self-check. For the peripheral equipment, the OC, SC overload problems are usually in the output side because they mainly check the output current. If the cable length is too long, just now as I introduced, there may be the harmonics current and leakage current in the long cable. Reactor and filters are needed at this time. If the motor cable is broken, it may short to the ground directly. If the cable joint or screw are not fixed well, it may also short circuit. If the water is full of sand, it may block the pump impeller and then display the overload problem. For the OU and LU fault, usually we consider it is the input power side has some problem, like if the solar panel installation is in shadow or the panel one piece in one string is broken. That could cause the totally one string panels doesn't work normally, and the voltage and power will be not enough and displays a low voltage problem. Or if the solar panel is configured too much, it may display over voltage problem. Some customers' solar panel quality is not so good, and the solar panel specifications is not same as what it mentions. So this time the VOC and VMP could be lower than the real than the mentioned value, and could also you consider the solar panel is enough, but actually they are not enough. And this time you could also use F14.00 to 0 for the VFD mode to check if the voltage is enough or not. There are also some other peripheral equipment reasons, like the motor and inverter module capacity doesn't match. You use a small power inverter to drive the big power motor, or you use a too large inverter to drive a too small power motor. They could also damage the VFD or damage the motor. If the protection grid or the cabinet design has some problem, like SI21, SI22, or SI23, they are IP20 protection, but they shall be installed in a cabinet, but you install outdoor directly. You will also find it, the inverter could be damaged easily. For the inverter self-check, I list the steps to follow. You need to disconnect the power cable and motor cable at first, and then test the IGBT. If the IGBT is damaged, and you try to run directly, there may be some sparks or even fire in the output terminals. If the IGBT is good, you could connect the power cable and test the AC and DC bus voltage, and then check the fault record. After that, you could make a factory default and run the inverter and check the three-phase output voltage. If the three-phase output voltage are all okay, that means the IGBT and the central part is okay. This time you could connect the motor and run again to check the three-phase current. If the three-phase current is balanced, this time that means the inverter is good. There are also some seldom reasons just now introduced. For the LU fault, you could also consider the cooling fan problem or contact problem. For the SC fault, here I want to emphasize it again. Please check and test the IGBT at first. In case the IGBT is damaged and you run directly and damage and fires burn the VFD directly. Here is another example for the error treatment. One day, another customer contacted me and sent a fault display. We could see it is E.OLF. Just now I introduced the E.OLF is output phase loss protection. The first time I see this fault, I think, okay, this customer may be used for a single phase pump. But actually, this customer, it is used for a single phase pump. So I told him to disable the output phase loss protection at first. And you could see the customer told me he already set the F10.15 to 0020. Actually, the output disable is just the 0 digit. So if it is 0020, means the output phase loss protection is already disabled. But why it still displays this fault, I asked the fault description from this customer. He told me previously the inverter runs normally, but after he did a parameter setting, the inverter suddenly displays this problem. He already forgot which parameter setting he did. Just know the inverter displays the OLF fault. So I tell him a very easy solution, try to make factory default. And then he tell me this fault is cleared and the inverter runs good. From this example, I want to tell you two things actually. The first, the video pictures and basic information, this is same as before. Another two suggestion is that first you need to follow the steps and we must collect the necessary information, especially for the fault description. That will help us judge the problem. Another thing is used in this phenomenon that one customer did the parameter setting and suddenly inverter display a fault. This time you could try to make F00.19 to 1 or 2 to make factory default. And then you will find 90% the inverter could run normally. For the damage treatment, I will just introduce some steps to test the components. We all know that VFD, no matter SI23, SI30, or the minimum size product SI22, SI21, they are all highly integrated product. It is almost impossible for the end users to repair the product. So most of our customers, they just need to know and they just need to learn how to test and find the damaged parts. Then we could arrange the spare parts accordingly. Let me introduce the VFD structure at first so that you could understand it better. VFD is mainly composed of hardware and software. The software mainly contains functions and parameters. If it is a performance problem like the abnormal working or some running frequency cannot be good or running performance is not good, this time we mainly consider the software or parameter setting has some problem. But if the inverter could run to 50 Hz and stable running at 50 Hz with load, just sometimes the inverter display a fault. This time we think the VFD hardware is good. Because for the hardware, if the output is good, the central part is good. For the hardware, we all know that VFD transfers the AC input power to DC power, and then through the IGBT transfer it to AC output. So the inverter hardware mainly consists several modules: the input rectifier module, the DC bus module, and output the IGBT module. Also, there is a pre-charge circuit and a breaking unit circuit. Because the inverter is using the IGBT to transform DC power to AC power, so actually the output is not a pure sine wave. It is a PWM wave. PWM is pulse-width modulation. So actually, the output consists of thousands of pulses. That's why for the long cable, there is actually resistance and capacitors between the cable and the ground. If the cable is too long, there will be the harmonics and leakage current. By the way, some customers, if they use a pump for maybe more than 5 years or more than 6 years, and then he uses the VFD suddenly, the motor could also be easily damaged. This is also due to the different wave of the PWM waveform and pure sine wave. And some customer may be wondered about the difference between solar pump inverter and PV inverter. This is also one big difference. For the PV inverter, it outputs pure sine wave. But for the VFD output, it outputs the PWM sine wave. So the PV inverter is quite different with the VFD inverter. And here we could see the structure of a 5.5 kilowatt VFD. We could see that include the plastic body, the heat sinks. There are mainly 3 parts: power board, control board, and the fan. So for small power, it is very easy for customers to know which part is damaged. If the fan is okay, you just need to control a new control board, and then you can know if it is control board problem or the power board problem. You can see the real picture of a 7.5 kilowatt inverter. In the power board, it integrates the IGBT, and this IGBT actually it integrates the rectifier module and IGBT module. It also has a relay. This is what I just said, the pre-charge circuit, and the DC capacitors. So in this small power board, it integrates several modules, and it is difficult for you to test which part is damaged, and it needs some professional test tools. So you just need to replace the control board and then you could judge. But for the big power inverter, you can see the picture for the 110 kilowatt inverter. The IGBT module, DC capacitor, power board, fan, resistor, contactor, rectifier module are all separated. So this time you could test some main modules and then you could know if the power board is damaged. No matter for the small power inverter or the big power inverter, actually the test process is similar with the error judgment. First, you need to disconnect the motor and just connect power and test the IGBT. Totally 12 IGBT tube drop voltage need to be tested. And then you could connect power and check the contactor, fan, and control board display. If they are normal, you could check the DC bus voltage. And then check the control board voltage point. There is 24 volt voltage, 10 volt voltage, 12 voltage in the control board. And after that, you could dismantle the VFD and check which part is damaged. Here I listed the test tools and test methods for these main parts. Like the IGBT, you could use the multimeter delta level to test the 12 tube voltage drop between the RS-to-UVW terminal and the plus-minus terminal. If this test voltage is between 0.3 and 0.7 volt, then it is good. For the contactor, you just need a relay. They are in the pre-charge circuit, so you just need to listen if there is any click sound. When you give power, you could know if the contactor works normally. If you find the contactor is click and off, then you know this contactor or contactor supply voltage has some problem. For the fan, you could use a 24 volt or 220 volt power, or you could just exchange the fan wire to test it. For the resistor, you could use multimeter resistance level to test the value. For the capacitor, you could use also the multimeter resistance or capacitor level to test the capacitance value and test the electric charging process if normal or not. For the Hall sensor, you could use a current clamp to check to compare the real amps and inverter detection display. For the control board, you could use the multimeter, and power board, you could also use the multimeter and oscilloscope to test the voltage point value and test the IGBT waveform. For the small power inverter, just now we know that the power board integrates IGBT, relay, and rectifier and pre-charge circuit in one board. But for the big power drive, like 110 kilowatt, as I just introduced, it has lots of power board. The main circuit power board, 24 volt power board, IGBT power board, IGBT drive board, and so on. So it is very complex for you to repair it. You just need to know how to check it. Like this power board, this is for a 75 kilowatt power board. You can see in this small power board, it contains 5 circuits. The first circuit is a voltage detection circuit, and there is some power point, like 5.5 volt point. The second circuit is the switching power supply circuit. The third circuit is the IGBT drive circuit. The fourth circuit is the IGBT is a current detection circuit, and the fifth circuit is a control circuit. Very integrated panels. And then with these test methods and the test meters, especially just now what I introduced, the multimeter and current clamp, when you go to site, please take the multimeter and current clamp and you could judge which part is damaged almost in 70%. If you could still not find the problem, please contact the distributor or contact our engineer directly. We could help you do the fault debugging and check the problem. In the final part, I provide a feedback table. We could see that I list the fault description, the motor specifications, the inverter specifications, and some parameters like the C02 parameters for the solar specifications, C01 parameters for the fault informations, and also the input AC power, no matter it is power grid or generator, the informations, and the solar panel specifications for the VOC, VMP, power and quantity, and each string, the panel pieces, and the motor cable length, whether you use the output reactor or not, and even the running time before damage. All these informations could be used to judge the problem. And the videos, pictures could help us a lot to find the problem. So this is my introduction, and thanks for your listening. If there is any problem, you could send us by WeChat or WhatsApp or even in the YouTube. We could check the problem. And now is the question and answer part. If there is any question, you could contact us, and then we could answer you directly. There are 20 minutes left for the question and answer part.